Hello, my name is Yogendra and I'm a maths teacher at askIITians. Okay, today we are going to do lecture number 2 on polynomials. So, as I told you in the first lecture, this chapter is really very important. Okay, we did the basics of this chapter in the first lecture, and today we are going to do the core of this chapter, which is like very, very important concepts. Like, first is what we need to do, remainder theorem, factor theorem, then splitting middle term method, and how do we get the zeros of a polynomial, right? That is also we'll see in detail more, right? So we discussed before also that this chapter has a good weightage, and not only the weightage, okay, it is like really important for your further grades also. Its concepts will be used, okay, in the other chapters. So that's why you have to remember this chapter very, very, very carefully. You need to understand the topics and you need to remember these all concepts. So let's get started, guys. Okay. So first comes remainder theorem. Now, what is remainder theorem? Okay. Now, remainder theorem you can understand in, it is like really important. Okay, again, and like remainder theorem. I believe you have done already what you have done, like this long division method. Long division you might be knowing already. So let me take the example here and let me show you like what is remainder theorem. I'll come to that remainder theorem exactly, but first let me ask you something, right? Let me take this example only here. X cube, x cube. I want to do just long division. I hope you know that much. Okay, and if you don't know, then also look at my working. Okay, what I'm going to do, because this is what you need to understand, and then we'll come to remainder theorem, because if you know long division and all, and when I show you this, okay, this way you will understand it more clearly. So 7x plus 10. So I want to divide this polynomial by what? X minus 2, right? I want to divide this polynomial by x minus 2. So what I'll do here, what is the thing I need to write here? X square, right? I believe you know that we need to write the polynomial in the standard form, and then here we match to the, what is the first term here, right? So x cube we will get, and then what else I'll get? Minus 2x square. Now we are going to subtract it here. So minus minus plus, in subtraction sign changes, so this first term will get cancelled, and what we will get here? Minus 2x square. Now next what we do, we write here minus 2 and x, so that we can make this term exactly here. So what, okay, let's bring this term, above terms also down here. So what I'll get here? Minus 2x square, minus 2x square, and minus minus plus, we get 4 times of x. Yes. Now we will make it plus. This is minus here. Sign change. Again, this term will get cancelled and we will get minus 11x plus 10. Now you can understand, okay, what should I multiply here? Minus 11, right? So that I'll get here minus 11x and minus minus plus 22. Now we need to subtract again. So here sign change and here minus. So minus 12 is what we got remainder. Now this is what our remainder. You can see here also remainder. Okay, let me explain you what is happening here. This is what our remainder. Now there are very, very important things we need to understand here. This is what our remainder we got. So here what remainder theorem says, actually remainder theorem is giving us the shortcut. You should not do this. You should not do the long division, right? Remainder theorem is giving us a shortcut to avoid this long division. Imagine if a more degree polynomial is there, and then you need to do so many steps to just to get to this remainder, right? So there is a shortcut to find out this remainder. And what is that shortcut? If you need to divide by x minus a, you just substitute x equals to a into this polynomial, and that's what happening here. X equals to 2, x equals to 2 is the what here. So 2 you substitute. So 2 cube minus 4 into 2 square minus 7 into 2 plus 10. So if you calculate this, 8 minus 16 minus 14 and plus 10, what are we getting? Minus 12, right? So this is what, okay, this is what remainder theorem helps us, okay, and okay, this is what we need to remember. So if now I hope you can understand, remainder theorem is what this simple terms here. If a polynomial p of x is divided by x minus a, then remainder is what? P of a, right? Or if I say in this example, if I need to divide this polynomial, this particular polynomial by x minus 2, so what is the remainder? Just substitute 2 here, because this is what p of x. So p of 2 is what our remainder, right? So this is how we can define our remainder. Okay, like we can find out the remainder without doing this much work, right? And that's what we need to use. We don't have time to do always like this. They say sometimes they mention do it without long division, right? They will mention that we need to do it without long division. So this is what remainder theorem, that is what our remainder theorem we need to understand. So remainder theorem is an approach of Euclidean division of a polynomials. According to this theorem, if we divide a polynomial x minus p of x by x minus a element, okay, so we get the remainder as p of a. That's all, right? This is what it is. You don't need to read this full thing. Okay, you can understand, right? This is what better definition is given down. I hope it is clear, and it is really important further. We are going to understand factor theorem. So if you don't understand remainder theorem, factor theorem is not going to be clear. So take time, make sure you are understanding what is explained here. I showed you the proof also. I know it was not listed, it was not shown here, but I showed you the proof, right? So this is what it is. One more thing you can remember here, one more thing you can observe here. What is the another thing which you can observe? That what is the degree of divisor? I know it is not that important right now, but you need to remember what is the degree here. Degree of divisor is 1. And what is the degree of remainder? 0. You need to remember degree of divisor is always greater than the degree of remainder, or you can say degree of remainder is always less than the degree of divisor. This is also really important concept. We will use it later, okay, but as of now you just remember, right? So these are the few things which you need to remember, okay? But remainder theorem, mean you understand remainder theorem, right? We can see, right, find the root of the polynomial. Okay, I think this we should do later, but let's understand this further, right? Find the remainder when this polynomial is divided by t minus 1. So I'll not do long division now because I know remainder theorem. So let's use, you will write for this question I'm doing using remainder theorem. So what it will be? T minus 1. So equated to 0, t is equals to 1, right? Now what is my p of t? P of t is what? T cube minus 2t square plus t plus 1. Now substitute t as 1 here. So 1 cube minus 2 into 1 square plus 1 plus 1. So what is it becoming? 1 only, right? Remainder is what? 1. This is what our remainder. We'll come to this root of the polynomial. We'll do by splitting middle term method. First we need true, and we'll come to the root of the first question is what to be answered later on, right? I hope it is clear. P of 1 is what? 1 here. Okay, we'll see this factor. Okay, first solution. As of now, you need to understand this. Okay, 2 plus 2. Okay, I think there is a mistake. Okay, it has to be 1. Yes. Okay. Remainder is 1, by the way. You need to cross check it. Okay, yes. Now we come to factor theorem. This is again very, very important. Okay. Based on remainder theorem only, we define factor theorem. So what here, the only thing is what we are going to use the same sentence if p of x is divided by a polynomial x minus a. P of x is divided by x minus a. Then what p of a, the remainder p of a becomes 0. P of a becomes 0. So that time x minus a is called as factor of the polynomial. So all the previous thing, okay, remainder theorem only, but remainder is going to be 0. If remainder, the remainder p of a is 0, then x minus a is called as factor of x minus a is factor of p of x. That's all, right? This is what the thing we need to remember for factor theorem. So this implies x plus a is a factor of p of x if p of minus a is 0. Ax minus b is a factor of polynomial p of x if p of a minus b. How we are getting this b by a? You can see this, okay. By the way, like x plus a is equals to 0. So x equals to minus a. Here, this one, ax plus b is equals to 0. So x equals to minus b by a. Right here, ax plus b. Okay, I did for minus it was, so it is plus. Right, now 0. So x is equals to minus b by a. Right, so that's how these values are coming here. X value, x is what we need to substitute. So what is it x equals to, right? Like that. Now if we have this, so p of a will be 0 and p of b will be 0. We'll see the examples and you will understand, but main thing is, what are you understanding factor theorem? When that value of polynomial becomes 0, that time it changes to factor theorem. Okay, and factor theorem says that x minus a is the factor of p of x. That's what we have here, right? So I hope it is clear. Let's see more examples, right? Show that x minus 1 is a factor of this polynomial. So there are two ways, okay. Now if they're not mentioning that you use the long division or without long division, we can do, first of all, we can do by factor theorem. So using factor theorem, right? Now, okay, x minus a is the factor. So x equals to what we are getting, 1. So if this p of x is what, this one, x cube plus 4x square minus plus 1, sorry, plus x minus 6, right? If it is a factor, then p of 1 has to be what? Tell me. P of 1 has to be 0. So 1 cube plus 4 into 1 square plus 1 minus 6. So 1 plus 4 plus 1 minus 6, which is what, 6 minus 6. So which is what, 0. So as it is 0, so x minus 1, so x minus 1 is a factor of p of x. That's all we say. Now you can always verify your answer if you want to do, otherwise not a problem. Okay, like you got the answer, you can verify your answer. You want to, if you want to verify, you can do long division also, but that method you need to avoid now, okay, because you know the better method and you need to do it faster also. You will be not getting only to do this. So if you have time, okay, you can use old method also, which is, what is the old method? If x minus a is the factor of this, so it should divide it completely, means we should get the remainder as 0. So let's try that. Okay, let's check that. Let's verify that. Here, x square I can multiply, so x cube minus x square divided by, sorry, subtracted from this. So what we get? 5x square plus x minus 6. Now I need to multiply by 5x. So 5x square minus 5x, then minus plus here, right? So what we get here? 6x minus 6. Now plus 6 here. So 6x minus 6, which is what, giving us 0. Did you get it? You're getting 0. So that's why it is a factor, right? But we need to use this method. Okay, this is the solution. You got it right. 0. So that's why it is a factor. Now factorization of polynomials, splitting middle term method. We need to understand that now, right? So let's understand that. Okay, let me take the example. It is really, really important. Okay, like I think I have the question next. As the name suggests, okay, splitting middle term method means we are going to do for 2-degree polynomial this one, right? This work. So let me take this x square plus 6x plus 8, x square plus 6x plus 8 equals to 0. And there is another example, which is what? X square plus 4x minus 21. Okay, should I take another example? Okay, like different example. Let me show you by different examples. Okay, first. We can always do those questions also, but let me take different examples. Okay, I'm going to take two quadratic equations again. Splitting middle term method is, by the way, for quadratic equations only. So let's see here. So suppose there is a question x square plus 5x plus 6 equals to 0. And there is another question x square mm, plus x minus 6. These are the two questions. Okay, we have. I need to do splitting middle term method. So you know what we do here actually? We look at this here coefficient and the last coefficient, a and b, a and c, like that you can say. So 1 into 6, which is giving us 6 here. But what is here? 1 into minus 6, which is what? Minus 6, which is what? Negative. And this is what? Positive. Right? Now 6 is the number. So its factors are 1 into 6, 2 and 3. There is no other factor here also. 1 into 6, 2 into 3. Now you need to split the middle term. We need to split the middle term here. So we split the middle term as sum of two numbers, which can give us, because it is positive, product has to come, product is what here? Positive. So we need to look at two numbers which are giving us middle term. So 2 plus 3 is what? Giving me 5. So I'll write here 2x plus 3x. 2x plus 3x plus 6 equals to 0, and this is what? X square already there, right? Now make pair, this pair here, this pair here. So x I can take common here, x plus 2, and 3 I can take common here, x plus 2. So we are getting finally x plus 2 and x plus 3. So x plus 2 is equals to 0 and x plus 3 is equals to 0. So we are getting x equals to minus 2 and x equals to minus 3. These are the zeros. Zeros of given polynomial. Right? Now for this, if we do this now, let's understand that. So here we need to choose which one, because here it is what? 1 here, right? 1 is the coefficient here. So we need to take these two. We need to choose these two. Here we have chosen these two, right? Okay. Okay, yeah, same only we are choosing here, because sum of these two and here difference of these two is what? 1. Like, should I change the question little bit, because I want to take the other one right here? Let me change the question a little bit here. We can always do that question also, but I want to show you the difference between the two things. Okay, here we have chosen this correctly. I want to write here 5. 5 here, right? It is 5 but minus here. So now what should I do here? Which two factors we need to choose? Which two factors we should choose here? These two. Why? Because I need to look for, first of all, it is negative. Negative means what? We need to look for the difference of two numbers. Difference of two numbers which can give me 5. So now 2 and 3 are not giving me difference as 5. 6 and 1 are giving me difference as 5. So x square plus 6x minus x minus 6 equals to 0. Now pairing up, okay, these two and these two. So x common, here we are getting x plus 6 minus 1 common, x plus 6. So we are getting x plus 6 and x minus 1 equals to 0. So x equals to minus 6 and x minus 1 is equals to 0, which is what x equals to 1. So there are two zeros here again. Okay, we are getting minus 6 and 1 here. I hope you're understanding. So minus 6 and 1 are zeros of x square plus 5x minus 6, right? These are the zeros of this polynomial, right? You can see clearly, right? Okay, by the way, you can cross check your answer always by substituting this x into this expression. Is it giving 0? Yes, it is producing 0, right? You should check both by substituting both. Okay, are you getting 0 or not, right? You can check this here also. So this is what this method, what I just showed you, is called as splitting middle term method, right? This is what our splitting middle term method. You can work out here also. I can just tell you fast here. 8, by the way, product is what going to be positive. So 8 is what, 2 into 4, 8 into 1, right? Like that we have. So which one we should choose? Because here positive, so sum of the numbers should be what, this one. So that's why x square plus 2x plus 4x plus 8, like this. So x plus 2 and here x plus 4. So x equals to minus 2 and x equals to minus 4. These are the zeros we have. I hope you are getting it right. Now the thing is what here, negative. Product is going to be negative, right? This into this is what, 1 into minus 21 is going to be negative, right? So that's why we need to look for two numbers ka difference. Now that is what, 21 is what, okay, 7 into 3. 21 into 1, right? This is also there, but 7 into 3 we need to choose. Why? Because difference I want as 4. So x square plus 7x minus 3x minus 21. So x plus 7 and x minus 3. You can do the with the steps. So x equals to minus 7 and x equals to 3. These are the zeros we have, right? These are the zeros we have. You can always practice it. Okay, you should practice more questions so that you get the complete hold of this topic. Okay, it is really, really very important topic. Okay, splitting middle term. Maximum times you will get to split this only, right? Okay, in cubic also we need to do this also, this only, right? Before doing cubic one, we need to learn this, right? Okay, these are the answers given. You can always cross verify your answers. Okay, here. Okay, now let's understand what are the roots of a polynomial. So whatever we found just now, these are called as roots of the polynomial only. What is the geometrical meaning of this all? Okay, if we graph it, okay, it cut the x-axis. So that is what geometrical meaning of these roots or zeros. Roots are zeros only. Whatever we found just now, those are roots. By the way, this is direct formula to solve this quadratic equation, but we don't need to worry about this much now. We can always learn it later, right? This one. So roots meaning is what, this only. Zeros we discussed, so those are roots only, right? What are roots? Zeros of a polynomial. So we just learned how do we find out the roots or zeros of a quadratic polynomial by splitting middle term method and equating it to 0 and all. Okay, like we get that like that, right? Okay, now check whether minus 2 is the root of this polynomial or not. So what we need to do? Root means 0 only. 0, right? So just substitute here. So p of x is given to us what? 3x cube plus 5x square plus 6x plus 4. So let's substitute p of minus 2 means what? 3 times of minus 2 cube, 5 times of minus 2 square, 6 times of minus 2 plus 4. So what it is? 8. It will be 8 minus 8, by the way. Minus 8 threes are 24 negative. Then here 4 and 20. Then here minus 12 plus 4. So what are we getting here? I believe minus 12. This is what the check whether the, okay, so what they said, okay, is it the 0 root? No, So we confirm if it is coming 0, then it is root, otherwise it is not. So x equals to -2 is not a 0 or root of given polynomial. Okay, it is not the 0 of the given polynomial, right? So that's how we understand it. It is not equal to 0. This whole statement is written, right? You can always practice these all questions, and if any doubt is there, what do you need to do? Using remainder theorem to determine whether x equals to 2 is a 0 of this or not. Just now I showed you one example. I believe you can do it. Find the remainder when this is divided by x minus 1. So you need to just substitute x equals to 1 here, and you need to check what is the remainder coming, right? It is pretty easy. Factorize each of the following quadratic polynomial by splitting middle term method. So again, okay, if you want, I can do this. Okay, this is also their root of the polynomial. Okay, so we can equate this also to 0. So we can do x square plus 2x. Now what is it? Negative, right? So what 3 5s are, so here 5x minus 3x minus 15 is equals to 0. So x plus 5 and x minus 3. So 3 and minus 5 are zeros. Here also 108, right? 108. Okay, okay, it is big number. Okay, let's see here. 2 5 4, then 2 27, then 3, right? Nines are like that. We want to split 21, so that sum should be, because positive, no, product is positive, so sum should be what? 21 here. So what should be two numbers whose sum should be 21? So now here 4 3s are 12, right? 12 plus 9, so x square minus 12x minus 9x, right? Like this we can do. So x minus 12 and x minus 9, this is what we are going to get. So you can see 9 and 12 are zeros, right? So you can always do it. Okay, okay, they were not asking for zeros in that case. Okay, they were just asking for the factors, right? We can do this easily, right? Okay, I hope you understood this. It is really important lecture. If you want, you watch it again, but get the clear understanding out of it. Okay, it is really, really very important for your further study of polynomial chapter. Okay, thank you very much for your time. See you in the next lecture.